To deal with challenges in soft robot design, this work presents a simulation and optimization toolbox for the design of the Bellow soft pneumatic actuator. The toolbox has two parts, simulation and optimization. Simulation parts takes input of the geometric and material parameters and provide a schematic visualization. Theoretical modeling analysis is workspace for fast and iterative design. After, the finite element methods takes input and generates a CAD file. It analyzes deformation and force in detail. To obtain an optimal design for specific objectives, optimization part takes initial design variables from simulation part. The optimization loop based on FEM is used to optimize geometric parameters to meet requirements. It outputs an optimal design, and after, the optimized design variables can be fed into FEM for detailed simulation. This is the interface of the simulation part. Users input geometric parameters based on the design guidance and can visualize the schematic SPA. They can select or input material parameters. Theoretical modeling analysis is workspace for fast, iterative design. Finite element method is used to simulate detailed results of angular deflection, blocked force, stress, and strain. And it also generates CAD file. Experiments validate the simulation results. The optimization part is similar but has a design optimization and a message panel. It will be used to conduct task-oriented design of the Bellow SPA. By extracting angular deflection and force requirements from the task, the FEM-based optimization aims to maximize the angular deflection and force, minimize the maximum principal strain, and avoid self-contact while fulfilling the performance requirements. Thank you for your attention.